All right, in this video, we're going to talk about section 3.7, and it deals with elasticity in demand. And in this video, we're going to be finding relative rates of change, also finding percentage rates of change. Also, we'll find the elasticity of demand and also determine whether demand is elastic, inelastic, or has unit elasticity. And then we'll find the values for which demand is elastic or inelastic, and also we'll look at some application problems that involve the elasticity of demand. All right, first of all, we're going to start off with the relative rate of change. And if you recall that f prime of x represents the rate of change of the function f of x. So here's a couple of definitions that we're going to start off with. The relative rate of change of a function f of x will be this: f prime of x divided by f of x. F prime of x divided by f of x. Okay, so you have to take the derivative of that function, and then that will be divided by whatever f of x is. Now, the percentage rate of change is similar to the relative rate of change. The only thing that's different here is we take 100 and multiply it by f prime of x divided by f of x. Okay. And if you think about this, by the chain rule, this is equivalent to the derivative of the logarithm of f of x. Okay. So if you have f of x and it's going to be equal to the log of the function f of x, then you can take the derivative of that by doing 1 over f of x times the inside derivative, which is f prime of x. Okay. So this ratio here is the same as taking the derivative of the natural log of f of x with respect to x. All right, so in example 1, here we're going to find the relative rate of change of the function f of x is equal to 120x minus 0.4 x squared. All right, so we'll start off with that f of x. I'm just going to rewrite the function. F of x is equal to 120x minus 0.4 x squared. So all we need to do there is just take the derivative of that function, which is, of course, f prime of x. So here we're going to take the derivative of each term since it's a polynomial function. So the derivative of 120x will be just simply 120 minus 0.4x squared. Its derivative will be, if I bring the 2 down, multiplied by the 0.4, you'll get 0.8. Copy the x down with the to the 1 less power. So f prime of x there will be 120 minus 0.8x. All right, so of course, the relative rate of change, as we just got through talking about, of the function f of x is this. F prime of x will be in the numerator divided by f of x, and that will be in your denominator. So f prime of x, we just found that out to be 120 minus 0.8x divided by the function itself, f of x. That's 120x minus 0.4 x squared. And I believe we can leave that as is, unless they want you to try to factor this completely and then do some dividing of common factors. But I think we can just leave that as is. Okay. Here's the second example. Here we're going to find the relative rate of change of the function f of x at the indicated value of x. So here we got f of x is equal to 6x squared minus ln of x. And here x is going to be equal to 3. Okay, so let me, excuse me. Let me rewrite the function f of x as 6x squared minus ln of x, and then find its derivative, f prime of x. For 6x squared, its derivative will just be, putting the 2 down, multiplied by 6, you're going to get 12, and then x, minus the derivative of ln of x, that's just going to be 1 divided by x. So I got 12x minus 1 over x for f prime of x. Now for the relative rate of change, that's going to be f prime of x divided by f of x. And f prime of x, that's just going to be that 12x minus 1 over x. And that whole thing is going to be divided by f of x. That's just going to be 6x squared minus ln of x. Okay, so that's the relative change of f of x. Now for x is equal to 3, we're going to find out what f prime of 3 is, and then what f of 3 would be in the denominator. So here we'll just do each and every x in the numerator and the denominator with 3. So it'll be 12 times 3 in the numerator minus 1 over 3. That's divided by the denominator, 6 times x, which is 3, and that's squared, minus ln of 3. Now, if I simplify that, 12 times 3 will be 36 minus 1/3 divided by, if I square this 3, that's going to be 9 times the 6 in front, that will be 54 minus ln of 3. All right, so if I do this in the calculator, I'm going to come up with the decimal value. So in this case here, this will be, in the numerator, I'm going to put that in parentheses. That will be 36 minus 1 divided by 3, close parentheses. Now that whole thing is going to be divided by, and then in the denominator, I'm going to use parentheses, so left parentheses, 54 minus, and then there's the ln key on the left-hand side. You'll press that, and that will give you ln, and then 3. You want to close the parentheses around the 3 for your ln, and then close it again, because I opened it when I started doing the division. Then hit enter. Let's say I want to give this answer to 3 decimal places. This will be approximately 0.674. Okay? So the relative rate of change of the function f of x at x is equal to 3 will be approximately 0.674. Okay. Take a look at example 3. Here I want to find the percentage rate of change of f of x at the indicated value of x. All right, now keep in mind the percentage rate of change means I need to give this answer as a percent. And here f of x is equal to 4,700 minus 2x squared, for x is equal to 45. Okay. So let me rewrite the function f of x. That's 4,700 minus 2x squared. And then f prime of x, we take the derivative of that. The derivative of 4,700 will be 0 because the derivative of a constant is 0. And therefore minus 2x squared. Bring the 2 down, multiply by the -2, you'll get -4. Copy over the x to the 1 less power. So f prime of x would just simply be -4x. Now the percentage rate of change is is given as this: 100 times f prime of x divided by f of x. Okay, so if I go back to here, the percentage rate of change is this: 100 times f prime of x divided by f of x. So that means I'm going to have 100 times f prime of x, that's negative 4x, divided by f of x, that's just going to be 4,700 minus 2x squared. All right, now if I simplify this, 100 times the negative 4x will be, in this case here, negative 400 divided by 4,700 minus 2x squared. And I think if I simplify this a bit, let me bring the negative 400 over. Actually, this should be negative 400x. Yeah. So it'll be negative 400x. Okay. Because 100 times the negative 4x will be negative 400x. Let's see. In the denominator, I got 4,700 minus 2x squared. If I factor out a 2 in the denominator, so here 4,700 divided by 2 would be 2,350 minus 2x squared divided by 2 would just be x squared. And then if I simplify this a bit, divide 2 into negative 400x, that would be negative 200x. So that means, excuse me, that means, and I'm going to continue this up here, the percentage rate of change, I'm just abbreviating this as PRC, for percentage rate of change, that would be equal to negative 200x divided by 2,350 minus x squared. Okay. Now for x is equal to 45. So now x is equal to 45. Your percentage rate of change, I'm going to label this as PRC again. That would be equal to negative 200 times x, which is 45, divided by 2,350 minus x, which is 45, and that's going to be squared. Now, if I do negative 200 times 45, that would be negative 9,000 divided by, excuse me, let's see, the denominator 2,350 minus 45, and that's squared. That would give me 325 in the denominator. And then negative 9,000 divided by 325. And if I was to round this off to one decimal place, this would be a negative 27.7. And I will include the percent sign because they ask for the percentage rate of change. So here, the percentage rate of change for this function at x is equal to 45 would be negative 27.7%. Okay. All right, example 4 would be this. Again, we're going to find the percentage rate of change of f of x at the indicated value of x. And here f of x is equal to 5,850 minus 3x squared, where x is equal to 25. All right, so again, I'll just rewrite the function. F of x is equal to 5,850 minus 3x squared. And then we're going to find f prime of x, find its derivative. So the derivative of 5850 is just going to be 0. But minus 3x squared, its derivative will be a negative 6x. So f prime of x will be negative 6x. Now for the percentage rate of change, and I'll abbreviate that as PRC for percentage rate of change, that's going to be 100 times f prime of x divided by f of x. So in this case here, this will be 100 times f prime of x, that's negative 6x, divided by f of x, that's going to be 5,850 minus 3x squared. So if I multiply that negative 6x times the 100, that will be negative 600x divided by 5850 minus 3x squared. And I'll do this, bring down the negative 600x, that'd be divided by, if I factor out a 3 in the denominator, 3 goes into 5850, 1,950 times, minus 3x squared divided by 3 will be just x squared. Then I can simplify this by dividing out the common factor there. 3 goes into negative 600x minus by negative 200x in the numerator. So this will end up being, for the percentage rate of change, negative 200x divided by 1950 minus x squared. So that expression represents the percentage rate of change. All right, so at x is equal to 25, the percentage rate of change, I'm abbreviating as PRC, is equal to negative 200 times the x, which is 25, divided by 1950 minus x, which is 25, and that's going to be squared. Negative 200 times 25 would be negative 5,000, divided by 1950 minus 25 squared. 1950 minus 25, and if I square it, that'd be 1325. Now, if I take that negative 5,000, divide that by the 1325, this will give me, let's say the one decimal place, that would give me, in this case, I'll say that the percentage rate of change, that give me negative 3.8%. So the percentage rate of change of the function f of x at x equals 25 would be negative 3.8%. Okay. All right, now on the next page, we're going to talk about elasticity of demand. This describes how a change in the price of a product affects the demand. We're going to assume that f of p describes the demand at price p. Then we define our elasticity of demand as this. It's going to be equal to negative relative rate of change in demand divided by the relative rate of change in price. Now notice here, there's a negative sign in front. And that's because F and P are always going to be positive, but F prime is negative, meaning higher cost means less demand. The minus sign will make the quantity come out to be positive. So that's where the negative sign comes in. All right, so now for a theorem that deals with elasticity of demand. If price and demand are related by X equals to some F of P, then the elasticity of demand is given by this formula. E of P is going to be equal to the negative of P, which is our price, F prime of P, divided by F of P. Okay, so here we're going to be using this in these examples here. Excuse me. In example 5, we got this. We're going to use the price demand equation below to find E of P, which represents the elasticity of demand. So in this case here, X is equal to F of P, which is equal to 15,000 minus 325P. So I'm just going to write this first as F of P, which is 15,000 minus 325P. So that's F of P. Now let's find its derivative. F prime of P is going to be this. All right, 15,000, its derivative will be 0. But negative 325P, its derivative will just simply be negative 325. And from that, we can find out what E of P is. That's equal to negative, and don't forget about that negative sign here, because that is part of the elasticity formula. Negative of P times F prime of P divided by F of P. So bring the negative sign over. And if you want to, you can put the negative with that P there, because if I did that way, it's going to mean the same thing. So negative P times F prime of P was negative 325 divided by F of P, which is 15,000 minus 325P. So this will end up being positive 325P when I multiply those two, divided by 15,000 minus 325P. Let's see if I can simplify this a bit. That denominator does have a common factor in it. And if I try to factor 325 out, that's going to give me a decimal. But the largest number that could go into 325 and 15,000, and I'll show you how to do this here. If I press the math key, go to the number menu and find the greatest common divisor here, and type in 15,000 and then comma 325, close parentheses, that would be 25. So 25 is the largest number that goes into 325 and 15,000. Factor that out, this will be 15,000 divided by 25, which is 600 minus 325 divided by 25. That'd be 13P. Okay. And if I divide 25 into 325, that would go 13P. That would reduce to 13P. So the numerator will be 13P over 600 minus 13P. Okay. So that is what E of P will be equal to, 13P divided by 600 minus 13P. So in this case, that would be our elasticity of demand function. All right, here's another example of just that. So sometimes, you're going to have to reduce or find common factors here. Like in this one, we got x equal f of p is equal to 5,500 minus 5p squared. And here we're going to use that price demand equation below to find E of P. So F of P, in this case, is 5,500 minus 5p squared. And if I take its derivative, F prime of P, the derivative of 5,500 is 0. The derivative of minus 5p squared will be minus 10p. Okay. And now if I do E of P, which is my elasticity function, that will be negative P times F prime of P divided by F of P. So I have the negative F prime of, well, P, negative P. Now I'll make that P negative. So it'd be negative P times F prime of P, which is negative 10P, divided by F of P, which is 5,500 minus 5P squared. So negative P times the negative 10P will be just 10P squared divided by 5,500 minus 5P squared. So let me bring over the 10P squared. In the denominator, I can factor out the 5. 5 is the largest number that goes into 5,500 and 5P squared. So if I factor out that 5, 5,500 divided by 5 will be 1,100. Minus 5P squared divided by 5 will be just P squared. And if I divide 5 into 10P squared, that would go 2P squared times. So I'm left with 2P squared in the numerator. That would be divided by 1,100 minus P squared. Okay. So that's how we find the elasticity of demand function. Okay. Now let's interpret the elasticity of demand. And here's the table just for that. E of P could be between 0 and 1, or it could be greater than 1, or it could be equal to 1. Okay? But keep in mind, it's never going to be less than 0. Now, if your E of P is between 0 and 1, that means that the demand will be inelastic. In other words, demand is not sensitive to changes in price. That is, a percentage of change in price produces a smaller percentage of change in demand. So as far as revenue is concerned, a price increase will increase revenue, or alternatively, a price decrease will decrease revenue. Now, if your E of P elasticity is greater than 1, then your demand will be elastic. That means demand is sensitive to changes in price. That is, a percentage change in price produces a larger percentage of change in demand. So for revenue, a price increase will decrease your revenue, or a price decrease will increase revenue. Now, if your E of P happens to be equal to 1, then your demand would be unit. You'll have unit elasticity. So a percentage change in price produces the same percentage change in demand. Okay. So with that, it will have no impact on revenue. Now let's look at example 7, because we're going to use that to help us answer parts A, B, and C. Okay. Get to it. Here we go. All right, in this example, we're going to use the price-demand equation below to determine whether demand is elastic, is inelastic, or has unit elasticity at the indicated values of P. So here we got X equals F of P, which is equal to 1,110 minus 5P minus 0.3 P squared. So let's first find out what F prime of P is, and then we can find out what E of P is going to be, our elasticity function. So F of P is equal to 1110 minus 5P minus 0.3 P squared. F prime of P is going to be this. The derivative of 1110 is 0. The derivative of minus 5P will be minus 5. And then minus the derivative of 0.3P squared, that's going to be 0.6P. So F prime of P will be negative 5 minus 0.6P. And then E of P is going to be negative of P times F prime of P divided by F of P. I'm going to bring the negative where that P is, so it'll be negative P times F prime of P came out to be negative 5 minus 0.6P divided by F prime of P, F of P, which is 1110 minus 5P minus 0.3 P squared. Now, if I distribute that negative P over the negative 5 minus 0.6P, this is what I would get. I get 5P plus 0.6 P squared divided by 1110 minus 5P minus 0.3 P squared. And that would be what E of P will be. Now we're going to use that to answer parts A, B, and C. So here we want to determine whether demand is elastic, is inelastic, or has unit elasticity at the indicated values of P. So in part A, you're going to have P is equal to 50. So that means in this elasticity function, we're going to substitute each P with 50. So that means E of P or E of 50 will be equal to this. We take this, replace each P with 50. So it'll be in the numerator 5 times 50 plus 0.6 times 50, and that's going to be squared, divided by 1110 minus 5 times P, which is 50, minus 0.3 times P squared, which is 50. Well, P is 50, and that's going to be squared. I'm going to do each one of these, numerator and denominator, separately. So the numerator will be 5 times 50 plus 0.6 times 50, and that's squared. The numerator will be 1,750. Divided by my denominator is this 1110 minus 5 times 50 minus 0.3 times 50 and then that's going to be squared. The denominator will be 110. If I take that 1750, divide that by 110, and if I rounded that off to 2 decimal places, that would be approximately 15.91. So my elasticity at 50 would be 15.91. And now I have to use that to determine whether I have a demand that's inelastic or unit elasticity. Well, notice that 15.91 is greater than 1. So that means that the demand will be elastic. Elastic. And what that means here is that the demand will be sensitive to changes in price, meaning a percentage change in price produces a larger percentage of change in demand. Okay. So that's part A. Part B. What about P being 25? So that means E of 25. You're going to use the same E of P formula and replace each P with 25. So that means I'm going to have 5 times 25 plus 0.6 times 25, and that's squared, divided by 1110 minus 5 times 25 minus 0.3 times P, which is 25, and that's going to be squared. So in this case here, the numerator, I'll do 5 times 25 plus 0.6 times 25, and that's squared. This gives me 500. The denominator will be 1110 times 5 times 25 minus 0.3 times 25, and that's going to be squared. That gives me, correction, I'm sorry, that should be a minus 5 times 25, and then minus 0.3 times 25 squared. That gives me 797.5. So if I was to round that up to 2 decimal places, I'd take 500 divided by 797.5. So 2 decimal places, that would be approximately 0.63. Okay. And if I look at that table that I have up here, 0.63 is between 0 and 1. So the demand there would be inelastic. So my demand would be inelastic. What that means there is that the demand is not sensitive to changes in price, meaning that a percentage change in price produces a smaller percentage of change in demand. Okay. All right, part C, where P is 30. So we're going to use our elasticity function at P is equal to 30. All right. So here we're going to have the numerator that'd be 5 times P, which is 30, plus 0.6 times P, which is 30, and that's squared. All that's divided by 1110 minus 5 times P, which is 30, minus 0.3 times P, which is 30, and that's squared. So in this case here, we're going to have 5 times 30 plus 0.6 times 30, and that's squared. The numerator would be 690. Divided by, my denominator will be 1110 minus 5 times 30 minus 0.3 times 30, and that's going to be squared. This will give me also 690. So 690 divided by 690 will be 1. So here, E of P is equal to 1. That means I have unit elasticity. So that means that the percentage change in price produces the same percentage change in demand. So that means at 30, at a price of 30, my elasticity would be unit. Okay. All right, on the next page, now I kind of talked about this in the table earlier, where revenue and elasticity of demand are related. If your demand is inelastic, then consumers will tend to continue to buy even if there is a price increase. So a price increase will increase revenue and a price decrease will decrease revenue. And the other bullet point, if demand is elastic, then consumers will more likely to cut back on purchases if there is a price increase. This means the price increase will decrease revenue and a price decrease will increase revenue. Okay. All right, now let's take a look at this example right here. Because in this case here, they're asking for two things here. They want you to use the price-demand equation to find the values of P for which demand is elastic and the values for which demand is inelastic. Assume that price and demand are both positive. And here you got X equals F of P, which is equal to 3,125 minus 5P squared. Okay. So first of all, what we need to do here is we want to find out what's happening here with this particular situation where it's going to be elastic and also inelastic. Okay. So let's take that F of P, which is 3125 minus 5P squared, and set that to be greater than 0. Let's start with that. So that means your F of P, that's the 3125 minus 5P squared, is greater than 0. All right, so here's what I'm going to do here. I'm going to get the minus 5P squared by itself. So that means I need to subtract 3125 on both sides. So that means negative 5P squared is greater than negative 3125. And to get P squared by itself, I'm going to divide both sides by negative 5. And if you recall, when you divide an inequality by a negative on both sides, the inequality symbol reverses from greater than, in this case, to less than. And then negative 3125 divided by negative 5 will be 625. So P squared will be less than 625. And then if I take the square root on both sides, of this inequality. And notice I'm not using plus or minus because our price is assumed to be positive. So that means our price can't be negative. So in this case here, P will be less than 25. So my domain will have to be some value from 0 to 25. And notice I'm using parentheses, not brackets, because I can't have a price of 0. It's got to be bigger than 0, but less than 25. Okay. Now, of course, my f of p would be 3125 minus 5p squared. What I'm doing here is just finding the e of p, that my elasticity function. And I have to take the first derivative of that. So f prime of p would be this. The derivative of 3125 is 0. The derivative of negative 5p squared would be negative 10p. All right. So E of P, of course, that's going to be negative P times F prime of P divided by F of P. So I have negative P times F prime of P was negative 10P divided by F of P. That'd be 3125 minus 5P squared. And if I simplify this, this would be 10P squared in the numerator divided by 3125 minus 5P squared. And I'm going to factor out the 5 in the denominator, because 3125 and 5p squared have a common factor of 5. I'll factor that out. 5 goes into 3125, 625 minus 5p squared divided by 5 would be just p squared. And if I simplify this a bit, 5 goes into 10p squared, 2p squared times. So I have a negative, no, not negative, positive 2p squared divided by 625 minus p squared. So that's your elasticity function, E of P. Now we're going to use this to find out the values for which the demand is elastic. Let's start with that. Now, if you recall in that last table that I gave you, for something to be elastic, it's got to be where E of P is greater than 1. All right, so we're going to find out the values of P where E of P is going to be greater than 1. So this is our E of P function, 2p squared divided by 625 minus p squared is greater than 1. And in this case here, that 1 would be 1 over 1. If I do some cross multiplication here, that would mean I'll have this 2p squared times the 1 would be 2p squared. That's greater than 625 minus p squared times 1 would be 625 minus p squared. And I'm doing this just so as long as my denominator is not 0. Now, let's get all the p squares on one side by adding p squared on both sides. That means I'll have 3p squared is greater than 625. Then divide both sides by 3, you'll get p squared is greater than, we'll leave this at 625 over 3 because I don't think 625 is divisible by 3. And then take the square root on both sides. We're not using plus or minus because P represents the price, and the price can be negative. And we're assuming price and demand are both positive. Okay, so we don't need that plus or minus symbol. Square root of P squared would be P, and that's greater than the square root of 625 is 25. 3 is not a perfect square, so we're going to leave that 3 underneath the radical. Okay, because the square root of 625, over 3 means the square root of 625 divided by the square root of 3. And the square root of 625 is 25. We leave the 3 underneath the radical. So whatever our price is has to be greater than 25 over the square root of 3. Okay. Now, our domain is restricted from 0 to 25 for the price. So that means for this, it can be greater than 25 over the square root of 3, but not more than 25. So that interval represents the price for which our demand will be elastic. Okay. Now, for inelastic, okay, I do this off to the side, inelastic, because they ask for the values for which the demand is inelastic. In other words, well, if our demand is going to be inelastic, that means your E of P has to be something in between 0 and 1. E of P must be between 0 and 1. 0 is less than E of P and less than 1. Our E of P in this case, I'm bring the 0 down, that's less than, your E of P is this right here, that 2P squared 2P squared over 625 minus P squared. 2P squared. Divided by 625 minus P squared. And then that's going to be less than 1. All right. All right, now here's what I'm going to do here. Since this is a compound inequality, I'm going to multiply each and every term by this denominator here. So this 0 will be multiplied by let me use a different color besides this one. This 0 will be multiplied by that 625 minus P squared. And then less than 2P squared over 625 minus P squared. That would be multiplied by 625 minus P squared. And then less than 1 times, and I'm running out of space here, 625 minus P squared. Okay. Now, when I do that, this right here, that 625 minus P squared times 0 is 0. Less than, and in this case, these 625 minus P squared, they divide out. You'll be left with this 2P squared in the middle. And less than 1 times 625 minus P squared will just be 625 minus P squared. And it will probably be best to write this as 2 separate inequalities. One will be this. 0 is less than 2p squared. That's this part. And then the other one, I'm going to add and this part right here, 2p squared, less than 625 minus p squared. Okay. And then solve each inequality here. So 2p squared, well, 0 is less than 2p squared. If I divide by 2, that means 0 is less than p squared. And if I take the square root on both sides of that inequality, that means 0 is less than p. So that means the price has to be greater than 0. And this one, 2p squared is less than 625 minus p squared. If I add p squared to both sides, that would mean I will have 3p squared is less than 625. Then divide both sides by 3. That would mean p squared is less than 625 over 3. And then take the square root on both sides. And all of this is underneath the radical. That means p is equal to, p is less than, the square root of 625 is 25. The 3 remains underneath the radical since it's not a perfect square. So in other words, what that means here is this. This includes the word and. That means that p is greater than 0 but less than 25 over the square root of 3. And that interval would be written like this, 0, 25 over the square root of 3. That is the interval where the demand would be inelastic. Okay, that's going to represent the values for which your demand is inelastic. Okay, and that's assuming that your price and your demand are going to be both positive. All right. And finally, example 9 looks like this. The price demand equation for hamburgers at a fast food restaurant is given by the equation below. Currently, the price of a hamburger is $4.50. If the price is increased by 20%, how will the revenue be affected? Okay, all right, in this case here, we need to write this equation, x plus 300p is equal to 3,500, in this form, where x is equal to some f of p. Here's what we have. X plus 300p is equal to 3,500. So to write this equation into this form where x is equal to something, we need to subtract 300p on both sides of this equation. That's to get x by itself. So that means that x is equal to 3,500 minus 300p. So now it's in the form x is equal to f of p, where this part right here, 3,500 minus 300p, represents f of p. So in this case here, f of p is equal to 3,500 minus 300p. Now we can take its derivative and find out what that elasticity of demand function would be. So f prime of p would be this. The derivative of 3,500 is 0. The derivative of negative 300p would be negative 300. So here, E of P would be this negative P times F prime of P divided by F of P. So here we got negative P times F prime of P, which is negative 300, divided by F of P, which is 3,500 minus 300p. So if I simplify this, this will be 300, positive 300p times 3,500 minus 300p. Let's see what I can do here. That denominator has a common factor of 100. So let's see if we can factor out 100 here. I'm going to bring the 300p here. The denominator, let's factor out 100. When I do that, 100 goes into 3,500 35 times, minus 100 goes into 300p 3p times, because that's 300p divided by 100. That's 3p. If I divide 100 into 300p, I'll have 3p. So that means this simplifies as 3p over 35 minus 3p. That would be my elasticity function. And in this case here, you're told that the price of a hamburger is $4.50. So that means here, our P is $4.50. This will be E of P. So E of $4.50. We just replace each P in this elasticity function with $4.50. So that would be 3 times $4.50, divided by 35 minus 3 times $4.50. Let's see, 3 times $4.50 would be 13.50 divided by 35 minus 3 times 4.50. This will give me 21.50. If I take 13.50, divide that by 21.50, that would give me, let's say to 2 decimal places, this will be approximately 0.63. Now, that's the elasticity amount. That value is going to tell me whether it's going to be inelastic, elastic, or unit elasticity. Going back to this table, 0.63 falls between 0 and 1. So that means your demand will be inelastic. So we can say that the demand is inelastic. And then the question that they ask for is, how will the revenue be affected? Well, if your demand is going to be inelastic, going back to this table, this is what's going to happen. And it does say that the price, if the price is increased by 20%, well, for the revenue, a price increase will increase your revenue. Okay. So we can say here that an increase in price will increase revenue. An increase in price will increase revenue. Okay, so that's how the revenue will be affected if that price is increased by 20%. Okay, so that does complete this video on section 3.7 dealing with elasticity of demand. Feel free to reach out to me if you have any questions about any of the homework problems that are in my math lab on this section, or any of the examples that were presented in this video.